of the vibrant colors of data he's using. So based on these two learning, can we give our test as brag or Cezanne? So for Cezanne, other friends are telling it to be brag. Who is right? Yes, it's brag. And you people decided it to be brag only from the images. Why? And how did we do it? Color intensity and color combination. Color combination, color intensity, and you might be also seeing there are strokes used with lines and patterns, curves, textures like no, sorry, patterns like lines. All the images of the graph, you can see it is in the form of lines, curves, pyramids or triangles or some features like this, which in our brain has processed the schooling learning where we usually use the drawings. And Cezanne is using the vibrant colors. There is no feature. He has used just the nature as his pattern of style of working. So based on these two artists, we our brain categorized it to be the brand. Okay. So this itself is meta learning. So from this, what did we learn is we learned that meta learning is a learning to learning. What is learning to learning? We have already the knowledge base available in our brains. We are trained with it, not on the same kind of data, but we have some part of training for lines. We have some part of training on curves and ellipse, eclipse, and every part of the data. We have our knowledge base, but based on this knowledge base, when we apply the same knowledge base on this image, our our brain extracted, the neurons of the brain extracted particular elements of that and gave us. We don't know whether it is 100% accurate or not, but 80, 70 or more than 50 at least, more than 50% of the images what we happen to see that it gave us that this might be a Braque image. Okay, so how did we accomplish? This is the learning to the learning, and this is how we are going to set the base for meta learning. So the interest of the meta learning started from 2017. It has come from 2017, and from last 5 years, it has grown into the huge potential. Why did it grow into the potential? Because deep learning and machine learning led us into hours of training or days of training. But this meta learning reduces our training process from hours, might be to some 2 or 3 hours or minutes. So this is how we are going using meta learning. Then let's learn what is this. Meta learning is described as a learning to a learning, where the aim of this meta learning is to create a learning algorithm that can quickly adapt to related tasks with less data. It is going to adapt with less data. Meta learning algorithms are using the meta. What is meta actually? When I tell meta, what is it? So meta means when I right click on any file, it gives me the properties. It gives me the properties. The properties can be the size of the file, when the file is created, and when who is the author of the file. All these data. The meta is also an important data of the particular file. Along with that, it is knowing all the content of that particular file. So it is not abstracting. It is the log data which the file might lead. Okay, meta learning algorithms are trained with predictions and metadata of other machine learning algorithms. See, it is in yesterday's class, Sir Ashok sir told that we have a bucket, huge bucket of artificial intelligence. In that again we have machine learning, and again in that we have deep learning. But meta learning is again within the deep learning. Okay, it is again within the deep learning. It is a part of deep learning, but what deep learning is doing, it needs huge data, but meta learning is learning from the deep learning, but with less data. Okay, so it needs the knowledge of machine learning, it needs the knowledge of deep learning. It has already built in all the data. The algorithms in meta learning, there are 5 to 6 algorithms in meta learning, and they already have learned the data, and they have their knowledge base ready with it. And what are we doing? We are just extracting the learned knowledge, applying it to the newly available data, and trying to merge the old data with the new data which are occupying, which are we are what we can tell is we are convolutioning it. The convolution of data, the predominantly learned data with the new data, we are going to superimpose it. Based on this learning, if the result is more than 50%, my machine is going to tell that it is the learned data. Okay, so this is how we are going to learn. I'll just read this out. Meta learning algorithms are trained on predictions of the predictions and the meta data of the other machine learning algorithm. Meta learning algorithms can generate predictions of their own and information that can enhance the performance and the results of the other machine learning algorithms. So it is going to enhance the result. Okay, so how it is done? We have supervised learning and we have unsupervised learning. Let's learn supervised learning. What happens in supervised learning? We are given with set of inputs in supervised learning, and with the set of inputs, we are going to apply some weights on it and some bias to it. Okay, based on the number of training happens, the algorithm is going to update its weights and the bias, and when it is finalizing its weight and the bias, it is going to give me the result y with the classification data what the data is. Okay, the same here this is the meta learning data. What is happening? It is going to learn with 5 images, and in this 5 images, what am I going to test? I am going to test the completely unseen data of the dog's face. What it has learned in this 5 images, it has learned a dog with entire face or entire body of the dog, but given a face, will my machine learning do it? Yes, it does it. How it is going to do it? It is going to do it with the algorithm given the supervised meta learning, where f of dtx where d raised to tr is already the knowledge base. It has the knowledge base. How it has gained that knowledge base? It has already gained the knowledge base from MNIST data, ImageNet data, then Kaggle, then with different resources available already, the algorithm is already learned. Okay, what are we doing here is we are just taking the known knowledge, applying with the unseen data, and processing it with the new training set, and my result y is produced with the learning. Making sense? Okay. So this is how, and we go on training all these data with giving us the test set, and ultimately when we test it, we are going to test with some unseen data and checking with the face of the lion and checking with the tumbler. So all these data are already fed, and once we know that, we are going to come up with the suitable answer. What is this? Okay, so how is this working? It has two phases. One is the training phase, the other one is the adaptation phase. In the training phase, the meta learning algorithms are trained on set of tasks, learning how to adjust the internal parameters or the architecture of the new tasks. So it is going to adjust. So as we learned the different weights and the biases, here also there are parameters which are going to be adjusted based on the new unseen data. And training phase adjusts in the adaptation phase with the meta learning algorithm. It is going to adjust its suitable parameters based on the small amount of data which we are going to train the task. So how is this? Here we have the data and we have the base learners. The base learners can be anything. It can be your simple machine learning algorithms. It can be our deep learning algorithms. It can be any base learning algorithms, or it can be an algorithm which you have written with simple perceptron. With a single perceptron also can be possible. It can be any base learning algorithms. So what are we doing? We are going to feed our network with simple base learning algorithms. And in with the base learning algorithms, what are we doing? We are separating out different features. As we did in the cola image, what did we do? We separated out an whole image of the cola with the eyes, ears, nose, body, and hands. Similarly, the base learners are going to break down the entire image into different learning perspectives. They are going to learn different learning perspectives of the features of the data given, and all those aggregated data are being fed to the meta learner algorithm. The meta learner will finally predict the data and give me the final output. So this is how your new unseen data. We have seen two images of the cola. Now we are seeing the third image of the cola, and ultimately we are going to tell that this is correct. But how our meta learning is going to tell? It is going to find the feature map based on the base learners. The base learners are going to take one feature of each of the image, identifying it as eye, nose, ears, hands, and legs. Based on these features, it is going to map the feature map, and the feature map is going to aggregate it as a head and a body, and ultimately the meta learning algorithm is going to predict whether this is a suitable animal. So how many types of meta learning are there? So these are meta learning algorithms where model agnostic meta learning, so MAML, MAML. So here there is a model given. With the model, it is going to segregate the suitable features of the model. Based on the features of the model, the meta learning algorithm is going to composite the data and give us the accurate data. So this model is MAML model is going to learn on the image input data. So it is going to learn on the image data, and image data is going to be segregated, and whatever kind of the image data, whether it is small data or huge data, it is going to identify based on the MAML technique. Metric based learning. Here we are going to learn based on the metric data. Metric data is the CSV data or any textual data. Based on the metric data, we are going to learn the algorithm. So based on our requirement, what meta learners are going to do? So we are going to use them. Here when we want to optimize the suitable algorithm, already available algorithm ResNet, VGG16 or any mobile net, any algorithm is already available, and we want to optimize the output because we are going to get the lesser output based on the given input data, and we want to optimize it. Then let's go for optimization based meta learner. And if it is needing the neural network with memory augmentation, we want to enhance the data which is already available, but the data is not huge data. We want to augment it more. Then we need memory augmented data where it processes its data capacity and learn it. And again, meta reinforcement learning. Here we have the agent which is going to decide it has wrong moves or correct moves. Based on that, the reinforcement data are learned, and it is going to decide the moves of that and assign the points to the learner. And based on these kind of data, we are going to learn this in meta reinforcement learning. Okay, these are 5 algorithms used in meta learning. Okay, so what kind of an input we have? Based on that input, the meta learners are going to work on. Each has different capacities. Every meta learning algorithm will not work on the same kind of an input data. If we have image data, then we are going to use MAML as the learner. If we have textual data, we are going to use metric based learning. If we want to optimize it, it is optimization based learning. If we want to enhance the data, memory neural networks. And if we want to work with unseen data, unsupervised learning, we are going to use reinforcement meta learning algorithms. Done? So let's focus on learning this metadata. How can it be useful in agriculture? So here, sir told us today that artificial intelligence has gone into a wrong diversion. Okay, so it might or may not be reducing the man force, but ultimately food is the requirement. Without food, you cannot survive, and hence meta learners can be useful in predicting the losses which are occurring in agriculture. Okay, so this is meta learning in agriculture. So how it is in agriculture in India? Not only this is paddy. This is